Think about making a bulletproof vest with this material, or else like making an ambient armor for the spacecraft to provide protectiveness from micrometeorite impacts. So what's going to happen is you would create multiple layers of this material, and when a projectile comes and penetrates those material, it will sequentially lose energy such that when it comes in contact with the spacecraft, it's not going to be causing severe damage.
I'm Brian Freshour, IP Manager at WRF.
And I'm Michael Carey, Licensing Manager at WRF.
It's our pleasure to nominate Ramathasan Tevamaran and Jizay Kai for the 2022 WRF Innovation Awards.
Their new lightweight carbon nanotube material has the potential to strengthen materials like protective equipment, armor, aircraft, and spacecraft.
Congratulations on this accomplishment, and we look forward to working with their team to further develop this technology.
My name is Ramathasan Tevamaran. I'm an assistant professor in the Department of Engineering Physics.
My name is Jizay Kai. I'm a postdoctoral research associate in Professor Salama's group in Department of Engineering Physics at University of Wisconsin-Madison.
Think about protecting soldiers and first responders from projectile impacts, or else protecting the electronics in your cell phones. Or in a very extreme situation, think about the space exploration where we have to protect our spacecraft from space debris and micrometeorite impacts and hypervelocities. When you think about this situation, you need to develop materials that are going to have exceptional mechanical properties such as strength and stiffness, as well as an ability to absorb energy very rapidly. On top of that, you also need thermal stability of these properties. So we try to develop material system that will afford this protectiveness in extreme environment. We came up with a nanofiber mat that provide exceptional energy absorption capabilities compared to the current technologies available. For example, compared with Kevlar, this material can absorb energy more than 6 times higher. The way we made this material is with very lightweight components starting with carbon. One of the very intriguing form of carbon is carbon nanotubes. These carbon nanotubes are about 1,000 times smaller than the diameter of the human hair. So these very tiny fibers, however, they provide exceptional strength and stiffness. So we made a mat out of these carbon nanotubes that already provide exceptional properties by exploiting the intrinsic nanofiber properties and the entangled interactive morphology.
We functionalize the carbon nanotube mats and use Kevlar nanofiber to reinforce them. And this hybrid nanofibers mat enacts a new kind of interfiber interactions called hydrogen bonds. And the hydrogen bonds are stronger and dynamic bonds. So as the material is deformed, so for example, as a bullet penetrates the mat at ballistic velocities, such kind of hydrogen bonds will break, reform, break again and again in a sequential fashion. And this process dissipates enormous amount of the kinetic energy from the penetrating bullet, therefore affording the protection desire of the materials. The components of the materials in this nanofibrous material, including carbon nanotubes and the Kevlar nanofiber, are highly thermally stable, which allows us to develop the thermal stable components for the space applications. Additionally, this material exhibits higher strength and the ability to retard local failure of the materials, which is highly desirable for the safety-critical engineering applications.
So we have tested this material system in large scale in quasi-static, very slow tensile testing. In dynamic testing, we have tested them under micro-projectile impacts by using a laser-induced projectile impact testing technique that we developed in our laboratory. So now we are working towards understanding the scaling laws associated with scaling these dynamic testing to larger scales, as well as we are also working towards material fabrication techniques that will allow the industries to rapidly adopt these technologies. We are excited about the prospects of our material making a difference in the first responders' life, as well as enabling the next generation of space missions with mission-critical material systems.